Good evening, students. Uh, Exercises on matrices done before. We are going to do some more sums from your textbooks. Insert the main book, miscellaneous exercises on it, and the exemplar book. Let us start with the miscellaneous exercise problems. You all go through. You just open your book, textbook. You all go through exercise, miscellaneous exercise on chapter 3, page 100, where sums are given this manner. The concept of induction, which you have learned before, is required for these sums. I can see there are three sums, number 1, 2 and 3 on miscellaneous exercises of chapter 3, page 100, where sums are based on the concept of mathematical induction. Let me start with number 3, where it is given that A equal to the matrix A is given as 3 minus 4, 1 minus 1. We are supposed to prove that, required to prove A to the power n equal to 1 plus 2n minus 4n and then n 1 minus 2n. To solve this sum, I will remind you the concept of mathematical induction, which you did in your class 11 course, that you need to remember the concept here. We'll be proving it. There are 3 steps in mathematical induction. That first, the starting one is inductive step, where you prove that it is true for n equal to 1. Then you go for inductive step, where you assume that it is true for n equal to some integer k, and then you prove that it is true for n equal to k plus 1. So for this sum, I will be starting that manner. For n equal to 1, a to the power 1 equal to a, you know, this is nothing but 1 plus, or you don't write, you just write the value of a to the power 1 first, which is based on this. A to the power 1, put n equal to 1 over there, 2 into 1, 4 into 1, 1, 1 minus 2 into 1. Therefore, a dashed is equal to 3 minus 4, 1 minus 1. This is the given matrix. So this implies that equal to A. So given relation is true for n equal to 1. This was our basis step. Now inductive step. Let us assume, let the relation, this relation be true for n equal to k. that is a to the power k equal to 1 plus 2k, k 1 minus 2k. Let this be true. We are supposed to prove that, required to prove a to the power k plus 1 equal to 1 plus 2 into k plus 1, 4 into k plus 1, 1 minus 2 into k plus 1. This is nothing but 2k plus 3 minus 4k minus 4 k plus 1 minus 2k minus 1. Okay, this we are going to prove with the help of matrix multiplication. How? A to the power k plus 1 is required to prove where we have assumed a to the power k equal to this thing, that. So you write now a to the power k plus 1 is equal to a to the power k is what? 1 plus 2k minus 4k, k1 minus 2k multiplied by the original matrix. It was 3 minus 4, 1 minus 1. Just multiply and see the result. This is going to be row by column multiplication, you all remember. 6k plus 3 minus 4k minus 4 minus 8k plus 4k, 3k plus 1 minus 2k and minus 4k minus 1 plus 2k. This is changed to 2k plus 3 minus 4k minus 4 k plus 1. So you can see that a to the power k plus 1, we got the form which we expected to get here. So if the relation is true for n equal to k, it will be n equal to k plus 1 also. And by mathematical induction, we draw the conclusion that the given relation is true for all integral value of k. Hence the proof. Okay. This is sum number 3 in miscellaneous exercise chapter 3. We are going to do few sums here. Let us do number 4. After 3, let us do number 4. If A and B are symmetric matrices, prove that AB minus BA is skew symmetric. Number 4. In such miscellaneous exercise we are doing, since A and B are symmetric, so A transpose equal to A, B transpose equal to B. By definition, we get A transpose equal to A and B transpose equal to B. Now AB minus BA transpose, I think you all remember the property here, x plus y transpose is x transpose plus y transpose, already explained in property of symmetricity of a matrices or property of transpose of a matrix, there we did. So you can take transpose here as well as transpose on this, minus B into A transpose. Now AB transpose is B transpose into A transpose, and this is A transpose into B transpose. B transpose you put B, A transpose A into B. So this is going to be, therefore, AB minus BA transpose is equal to B into A minus A into B. This is nothing but minus of AB minus B. So this implies AB minus BA is skew symmetric. Okay. Done. Number 4. Let us go for next problem, number 6, where they ask you to find the values of x, y and z if the given matrix A equal to this thing 0 to yz, x, y minus z, x minus yz satisfies the relation A into A transpose equal to I. This implies if you take the transpose of this matrix 0 to yz, x, y minus z, this multiplied by A transpose is 0 x x. You know how to take the transpose? 2y y minus y, z minus z z is equal to I. Multiply these two matrices, again row by column. Multiplication this by this, it will be 0 plus right bigger. So row by column it gives 4y square plus z square. Now this by this it will give us 2y square minus z square. This by this 2yz plus z square. Then this by this it will give us 2y square this by this x square plus y square plus z square. This by this x square minus y square minus z square minus 2y square plus z square then this by this it will be equal to 1 0 0 0 1 0 0 0 1. Now you go for comparison. If you compare 4y square, comparing we get 4y square plus z square equal to 1, 2y square minus z square equal to 0, and then one more you take, it will be enough, because from these two you can get the value of y, z, and then you compare this way, x square plus y square plus z square is 1. I am comparing this element with this. So you just solve these two, adding 6y square equal to 1, y equal to plus minus 1 by root 6. Now z square is 2y square, 2y square 1/3. Can you see the board? This implies z equal to plus minus 1 by root 3. Now this thing that x square equal to 1 minus y square minus z square, 1 minus y square will be what? 1 by 6. Z square will be 1 by 3. 6 LCM 1 plus 2, 1 minus half, so x will be plus minus 1 by root 2. This way you can get its value. Now go through some number 7 or 9. They are similar type. Number 8 is a very simple problem. You'll just find the square of the matrix and substitute there and check whether the result is coming a zero matrix or not. Don't be confused with the 0 given on the right side of 8. It is 0 matrix. Okay. In a matrix equation, if 0 given on right side, this is definitely a 0 matrix. Okay. So let us do some number 7 or 9. Let me do number what? Which one? Let me do some number 9. Appears to be more difficult. So going to do number 9. For sum number 9, x minus 5 minus 1 multiplied by 102 021 203 multiplied by x41 equal to 0. So this implies this matrix is of order how many rows? 1 row, 3 columns. This is 3 cross 1. Multiplication will give you what? It will be getting a 1 cross 1 matrix. Then multiply with this. This is a 3 rows and 1 column. Okay. So this one first row 3 columns. This one 3 rows 3 columns. Sorry, 3 rows 3 columns, and this is 3 cross 1. We'll multiply step by step. First multiply this with this. If you do row by column, this is going to be x 0 minus 2. X minus 2. This by this, it will give you 0 minus 10. Minus 10 only. Then this by this, 2x minus 5 minus 3. 2x minus 8. Check once more. This by this, x minus 2. This by this, it will be minus 10. This by this, it will be 2x minus 5 minus 3 minus 8. This multiplied by x41 equal to 0 matrix. Now this matrix is of order 1 cross 3. This is 3 cross 1. So multiplication will give you 1 cross 1 matrix. So ordinarily this will be multiplied. X square minus 2x minus 40 plus 2x minus 8. Here 0 matrix will be 0 only 1 plus 1 matrix. So x square minus 48 equal to 0. So this implies x equal to plus minus root 48. At home we'll check all the steps and report me if any step I have done some mistake. You must report. If you go through the problem, then only you can find it. Check all the steps. Procedure is correct. You must report whether you have understood or not. Then let us go for sum number 10 here, where manufacturer produces 3 products X, Y, Z, which is sells in 2 markets. Annual sales are indicated below. Go through the sum once. If unit sale prices of X, Y, Z given, find out total revenue in each market with the help of matrix algebra. If unit cost of above 3 are this is simple, similar to part A. So let us complete 10 part A first. So to find the total revenue, we will be arranging from 2 markets separately. Total revenue each market with the help of matrix algebra. Market 1 is given in this row, first row here, that is 10,000. Product, one product is costing 10,000. The other one costing 2,000. and the third type costing 18,000, and for second one it is 6,000, 20,000, 8,000. This multiplied by 2.50, 1.50, 1.00. If we multiply, this will give us the first row for 1. This is written here. This is number 2. For 1 you will get this row. For 2 you will get in the second row. If we multiply, then first two elements coming like this. 10,000 and 2.5, 25,000, plus 30,000, 55, plus 18, 73,000. You understand? This by this, row by column. 25, 30 and 18. 55 and 18, 73. And here 6,000 and 2.5, that is 15, plus 30, 45, plus 8. So here you got the answer. That is total revenue for first one is rupees 73,000. For second one is 63,000.